Hello students, today we are going to take up the topic OXY acids of halogens. This is part 4 of group 17 elements under P block plus 2 inorganic chemistry. So let us start this topic with a very good thought. Life is the most difficult exam. Many people fail because they try to copy others, not realizing that everyone has a different question paper. So because everybody is having different qualities, if you try to emulate others, copy others, so you will not be able to pass that exam with that marks which you are capable of. So try to be yourself. You find your inherent qualities, your strengths, and definitely you will be unique. So let us start the topic. The learning outcomes. The students will be able to explain about the oxy acids of halogens. Structures and acidic properties are there in our syllabus, so we will take up that. So under this category you can see that HClO, that is hypochlorous acid. Next is chlorous acid, HClO2. Similarly chloric, HClO3. Perchloric, HClO4. So you should be aware that chlorous and chloric oxygen is more, hypochlorous oxygen is least, and perchloric oxygen is having maximum. This only you have to keep in mind. And you can see that in the first case, hypochlorous oxygen can form two bonds, that's fine. And similarly, oxygen here also is forming two bonds, there are also structures, finding that way it will be easy for us. Similarly, chlorine here is forming in chloric acid 5 bonds it is formed, and in perchloric acid 7 bonds are formed with chlorine. Okay, so take care of that. So let us start on the topic oxy acids of halogens. Fluorine, you can see from the table here, fluorine is forming only one oxo acid. So what is the reason for that we will discuss. But other chlorine bromine iodine form 4 series of acids. Just now we discussed hypo, chlorous, chloric, perchloric. Hypo least oxygen, perchloric maximum oxygen, halous 2 oxygen, halic 3. Okay. So similarly, when we are talking of oxidation state, we can calculate oxidation states by calculating x minus 2 plus 1 is equal to 0. So x will be 1 in case of hypo. Halous it will be 3 and halic 5 and perhalic 7. Please do remember that more the oxidation number, more will be the acidic character. So now the question is oxy acid of fluorine only one oxo acid. Why? The answer is written in your slide. Just see, fluorine forms only one oxo acid, that is fluoric acid or hypofluorous acid due to high electronegativity of fluorine and small size of fluorine. Okay. Next is stability of oxo acid. Other oxo acid we are talking of chlorous, chloric, perchloric. And I would like to tell you that these hypochlorous acids are very good oxidizing agents. And they are as well as bleaching agents. Why? Because you see that if you are taking off HClO, let us say first, that is hypochlorous acid, HClO. HClO will give rise to HCl plus oxygen, nascent oxygen. So they are providing oxygen very easily and they are not much stable and they cannot be isolated in pure state, and they are stable only in aqueous solution. Okay, so therefore they are using as a very good oxidizing agents. Fine. So these examples earlier also we have discussed. Sometimes, for example, here it is written HOClO. So you can write simply HClO2. Here you can write HClO3. Here you can write HClO4. So perchloric acid. So this is perchloric acid, and this is the most strongest acid. Okay. Next is oxidation state. We have already discussed. This is just a revision part. Hypo, halous, halic, perhalic. So this we can find the oxidation states. We have already discussed that it should be plus 1 for hypohalous. For halous it would be plus 3, halic plus 5, and perchloric, perhalic plus 7. Okay, so these are the structures also. for X is here halogen. Okay. Now, so this way the oxidation state again, if we are talking of here the first one, hypochlorous, here HClO2, this is chlorous, chloric, HClO3, here perchloric, HClO4. Okay, more is the oxidation number, more is the acidic strength. So acidity, as we discussed earlier also, more is the oxidation state, more will be the acidic character. See here, thermal stability and acidic strength increases. Now, if for example we are saying same like HClO, HBr or HIO, in this case only +1 oxidation fall, what will be there? So here you can see from acidity decreases. It means more is the electronegativity, more is the acidic strength. Okay. So if I want to compare for HClO4 and which is the strongest acid of all these acids which we have written here. First you can see maximum oxidation state should be +1, +7 or HClO4 or HIO4. Now you know that chlorine is having maximum electronegativity. So this perchloric acid is the strongest acid known. Okay, it is even stronger than the sulfuric acid, nitric acid, sulfuric acid. So we can say that HClO4 is the more stronger acid as compared to HClO because of more oxidation state. So what is the reason behind that? Now you see +7 is the more oxidation state, that's what we are saying. But what is the basic reason? Now each of these acids, when release proton, it will be having negative charge. If HOCl will release proton, OCl negative. Similarly ClO2 negative, ClO3 negative, ClO4 negative. Now you see negative charge is dispersed over 4 oxygen in case of HClO4, but negative charge is dispersed over only 1 oxygen in case of HClO. So therefore more is the dispersal of the negative charge, more stability of the ion will be. So if acid is having stable conjugate base, that acid will be more stronger. So this is the basic reason. The conjugate acid base theory, as per that, the base, if it is more stable, thus acid will be the strongest acid. Now which is more acidic, HOF or HY? So we can say that electronegativity is more. So fluorine is having more electronegativity and small size, so it will attract the bond pair, release of proton will be easy, therefore HOF will be more acidic. Now uses aqueous solution of perchloric acid, HClO4, is used in the estimation of potassium in gravimetric analysis. Okay. Now let us revise what we have discussed. The oxides of halogens are powerful oxidizing agent and decompose with explosive violence on being heated. Fluorine only form one oxo acid, hypofluorous acid, whereas chlorine, bromine, iodine form hypohalous, halous, halic and perhalic. Acid strength of hypohalous acid decreases with the decrease in electronegativity. Acid strength of different oxo acids of halogens increases with the increase in oxidation number. So let us understand and test your ability to for the question. Explain why fluorine forms only one oxo acid. The fluorine form only one oxo acid because of its high electronegativity and small size, and in this is having the oxidation state of +1. Okay. And due to the absence of d orbital, fluorine can't expand its valency beyond +1. Hence, fluorine does not form higher oxo acids such as HFO2, HFO3, HFO4. Okay. Next is uses of ClO2. This is oxides of chlorine, and you know that it uses bleaching agent and it's also oxidizing agent or chlorinating agent also. So write the reaction of fluorine and chlorine with water. So fluorine on reaction with water gives rise to HF. Similarly, chlorine when react with water gives rise to hypochlorous acid. Again, it can give us the oxygen. So congratulations. So I am sure that you will be knowing these answers. So let us repeat the thought for the session is life is the most difficult exam. Many people fail because they try to copy others and not realizing that everyone has a different question paper. Thank you.